All right, guys. So today we're gonna continue with yesterday's stuff on chords and radiuses, but now we're gonna also include Pythagorean theorem, which you guys should be familiar with it. Now, if this was like yesterday, so a little review on yesterday, I see that 17 is a radius. I see another radius here. I see part of it is 6.9. So if x instead of being there, if x was here, I would say 6.9 plus x equals 17, and I'm good to go. Because a radius equals another radius. That was from yesterday. But that's not the case. I see x is part of a chord. So I know this segment in the center cuts the chord in half. One side is x. If I knew the other side, x equals that, and we're good to go. But that's not the case. That's what we saw yesterday. Now, for today, I see 6.9, I see x, and I see 17. Together, they make a a right triangle. I remember a formula you guys have been told, a squared plus b squared equals c squared, Pythagorean theorem. Some people don't know it by the name, but Pythagorean theorem. That theorem is used when on a right triangle, you know two sides and you want to find a third side, which is our case. Now, which one is A, which one is B, it doesn't matter. As long as C is the biggest side, which we call the hypotenuse of the triangle, right? The big side, which in this case, 17. That's my C. The others are A and B. It doesn't matter which one is which. So I'm just going to write this as x squared plus 6.9 squared equals 17 squared. Follow me so far? Mm-hmm. All right, I want to know what 6.9 squared is, and I want to know what 17 squared is. So I'm going to use a calculator for that. I get that x squared plus 47.61 equals 289. I just did my squares. I'm going to subtract 47.61 from each because I want to leave the x squared alone. So we're going to get that x squared equals 241.39. That's what x squared is. Yes. How did I what? In a minute. Because we're not there. So here, that's what x squared is, but I'm asking you what x is, not x squared. So let me do the square root of each. So x, right, the square root of 241.39, rounded to the nearest tenth, is going to be 15.5. And I think that answered your question. So x squared equals 241.39. Do the square root to each side. So that's what x is. Good? Same thing I'm going to do for question number 2. I see 15, 8, and x make a right triangle. I know two sides. I can find a third side. I look at the measurement. I look at the length of the three sides. It looks like x is the biggest, so that's my C. So I'm going to go 15 squared plus 8 squared equals x squared. So now I leave x squared by itself because that's my hypotenuse. So 15 squared, that's 225. 8 squared, that's 64. And all this is equal to x squared. On the left side, 225 plus 64, that's 289. So 289 equals x squared. Let me get the square root on each side to find out what x is. The square root of 289 is 17. That's it. So see, that's why I'm calling it Pythagorean theorem. We have certain thing about chords, so chords Pythagorean theorem. So far, so good? Okay. Now, let's take a look at something like number 3. This one's going to require a little bit more work. I see that one side of the triangle is 19. I see the 40.4 as a diameter because it's in the center. So 40.4 is the whole diameter. I'm going to split it into 2. So 40.4 divided by 2 going to tell me 20.2 for each of the radius. right? I split the diameter into 2 because I only need the radius on that triangle. And then the third side, I'm going to call it y. I don't know how big is it, but I cannot call it x because x is already used. So I'm going to call it y. Now looking at that triangle, I'm going to say y squared plus 19 squared equals 20.2 squared. Let me solve for y. I need to find out what 19 squared is. According to my calculator, that is 361. 20.2 squared is 408.04. Let me subtract 361. So I get that y squared equals 47.04. Let me get the square root of that. And I get that y is equal to 6.9. That's what y is. So let me just come and write 6.9 over here. However, this whole thing is it's a radius. So the whole radius, I want to change this to blue. The whole radius is 6.9 plus x. That's how I'm going to be able to solve for x. The whole radius is 6.9 plus x. You guys see it in purple. I'm going to let this equal to another radius. Remember, a radius is from the center all the way out. I'm looking at 20.2. So I have the 6.9 plus x equals 20.2. Let me subtract 6.9 from both sides. X in this case is 13.3. So I have to solve for a little piece, which I'm going to call y, in order for us to solve for x. Same thing with question number 4. I see that the radius is 21.1, the radius. Remember, radius is from the center all the way to the edge of the circle. So if I draw another radius here, I'm going to call it 21.1. And the reason why I draw that radius is because I want a right triangle. The third side of the triangle, I'm going to call it y. So looking at that triangle, I can solve for y. I'm going to go y squared plus 17.5 squared equals 21.1 squared. Let me find out my squares. So I have that y squared plus 306.25 equals 445.21. Let me subtract 306.25. So I get that y squared equals 138.96. Let me get the square root of that. And I get that y is about 11.8. I'm looking at a radius. That's a radius. That radius is x plus 11.8. I'm looking at another radius, 21.1. So I have that x plus 11.8 equals 21.1. Let me subtract 11.8. I get 9.3.